Hello students, we are still on circle geometry. Now today we are looking at alternate segments. Alternate segment. Before we continue on alternate segment, I would like us to do some type of experiments. Now look at this. What do we mean by alternate segment? For you to be able to get this better, now first of all, if you are having this to be a circle, so you draw a circle. If you are having this to be a circle, this is a circle now. We are having this to be a circle. Now if you now draw a line that is a chord. From when you talk of a chord, a line that runs from one to this, from the circumference of the circle to the other end of the circumference here. So this is a chord without passing through the center. This line is joined from the circumference of this circle from this end to the other end without passing through the center of the circle. Now if you now have another line that join a line that touches that point where this chord touches the circumference here, so that is ruled outside like this. So this line is known as a tangent. If you have a chord and a tangent to a circle, at that point where of the tangent and the chord, now the angle this chord makes with this tangent, the angle the chord makes with this tangent will be equal to the angle this chord will make with any part of the circumference of the circle. The angle this chord is making with this tangent. If you now look at if you use this chord to draw a triangle inside the circle, let's try it. You use the chord to draw a triangle inside the circle. You use the chord to draw a triangle inside the circle. You realize that the angle this chord is making with the tangent will be equal to the angle this chord will make on the circumference of the circle. So this angle and this angle here, they are alternate segment. So that's the concept of an alternate segment. When you have the chord and the tangent to the circle, at the point of the tangent to the circle, any angle this chord is making with the tangent is equal to the angle this chord will make with the circumference of the circle if it is used to draw a triangle. So the line the chord makes with the tangent is equal to the angle this chord will make with the circumference of the circle if is used to draw a triangle. Now let's move on in the explanation. We are talking of an alternate segment. So I've just explained what an alternate segment is. So if a straight line touches a circle and from the point of contact of your chord is drawn, the angle that the chord makes with the tangent are equal to the angles in the alternate segment. So let's look at this diagram here. So you realize that this is a chord and this is a tangent. So the angle this chord makes with this tangent is equal to the angle it will make when it is the chord will make with the circumference of the circle when it's used to draw a triangle. So the angle here will be equal to this one. So let's look at this other side. If we are talking of what if this is a chord, now so if this is the chord, this from here to this place is a chord. Now if then that means the angle this tangent, and you're having this to be the tangent, the angle this chord we make with this tangent here will be equal to the angle to make if you use this chord to draw a circle touching the circumference. So the angle here will be equal to the angle we are having here. So they are alternate segments. Let's look at another diagram. You are having this line to be the chord. This is the tangent. So the angle this tangent makes with this chord will be equal to the angle to make if this chord is used to draw a triangle touching the circumference of the circle. So the angle here will be equal to the angle here. So this is known as alternate segment. Look at this diagram also. If this is the circle, if you are considering this one to be the chord, so this is the tangent. So the angle this tangent and this chord makes with this with this tangent should be equal to the, you are talking of this to be the chord, this is the tangent, the angle here will be equal to the angle to make with the circumference of the circle. So this and this are alternate segments. Now let's do some example. Now let's look at this first example. Now this is the circle, this is tangent, you are having this to be the triangle here. Now you are told that in the diagram PQX is a tangent to the circle QRS. Calculate SQX. So that means you are told to calculate this particular angle. The angle between this line, that is the chord, and the tangent. Normally you realize that since you are talking of this chord and the tangent here, this angle between them here should be equal to the angle this chord will make with the circumference. So it should be equal to this one. And we know, though we are not told to look for this one, but you can use the sum of angles in a triangle to get this third angle. 55 plus 48 plus this angle should be equal to 180. So SRQ, they are talking of this angle plus this angle 55 plus 48 should be equal to 180. You must state your reason. Sum of angles in a triangle. So SRQ will now plus 55 plus 48 to give us 103 is equal to 180. Bring this 103 to this side, we are having minus 103. SRQ should be equal to 180 minus 103, which is equal to what? 77 degrees. It means this angle here should be 77 degrees. So now you now realize our angle SRQ, this angle is now alternate to this angle. So because you can see this is the chord and this is the tangent. So the angle this chord and tangent is making will be equal to the angle it will use to, if it is used to draw a triangle on touching the circumference. So this angle and this angle is equal. So that means angle SRQ should be equal to angle SQX, the angle we are told to look for. Why? They are alternate segment. You must always give your reason. So that means therefore your angle SQX is 77 degrees. Now let's look at another example. You are having this to be the question. So you are told that this angle here is what? 82. In the diagram, PT is the tangent to the circle ABCT. BA, this line and this line are equal, showing that this one is giving us an isosceles triangle. And ATP, this angle here is 82. Calculate BCT. You are told to calculate the angle that is here. You are told to calculate the angle that is here. Now, to calculate this angle, before you can calculate this angle, first of all, you know this angle is what? 82. Now this is a chord, this is a tangent. This angle here should be equal to the, you can see this chord makes this triangle, so this angle with the circumference shows that this angle here and this one, they are what, they should be equal. Why? They are alternate segments. So let's try to solve it. So that means our angle ABT is 82 degree. They are alternate segment. This is ABT. You are talking of this angle here. So this angle and this angle, they are going to be equal because they are alternate segments. Now if you now have, so that means our BTA, this angle, since this here you are having an isosceles triangle, this is an isosceles triangle. You've known that this angle here is 82, and since we are having this and this line to be equal, this angle here and this angle here will be their base angle. Since base angles of an isosceles triangle are equal, you can use x to represent it. So that is why you're having the angle BTA should be equal to angle BAT. BTA, this angle. BAT, this angle. So they are going to be equal. So we can use x to represent both of them because they are base angles of an isosceles triangle. So it now means that this angle here plus this angle here plus this angle here should be equal to 180. Why? Sum of angles in a triangle. So and we already know that what the angle here is what? 82. And we said we should use x to represent each of the equal angles. So that means 82 plus x should be equal to 180. So 82 plus x will give us 2x, should be equal to 180. This 82, let's bring it to this other side. It will now turn to minus 82. 2x should be equal to 180 minus 82. 2x should be equal to 180 minus 82 will give us 98. So to get the value for x, divide both sides by 2. So that means the value for your x is what? 49. So that means each of the equal, in the value for each of this equal angle here and here is what? 49. Now if you now look at this, if this is 49, this is also 49. Now if this is 49, now if you now consider the whole shape in the circle, is this one gives us a quadrilateral. This one gives us 1, 2, 3, 4. It has 4 sides. That is a quadrilateral. And one of the theorem says that opposite angles of cyclic quadrilateral are equal. Since you have been able to calculate this, we are told to look for the value for this one. You can see that this angle here and this angle here, they are opposite angles in a cyclic quadrilateral, and they should be equal to 180. So since you have known this one to be 82, so it means 82. So 82 plus this angle should be equal to 180. So we know that your BAT is 82. Then this BAT is 49. 49 plus this BCT. So BCT plus BAT should be equal to 180. We've calculated BAT, this angle here, to be what? 49. So the angle we are told to look for, BCT, this angle. So BCT plus 49 should be equal to 180. So if we bring this 49 to this other side, now turn to minus 49. So the angle you are now told to look for will be what? 180 minus 49 will give us 131 degrees. 131 degrees. Now for the work practice, look at this diagram. So this is 48. So this gives us an equilateral triangle. This is tangent to the chord here. So the question in the diagram, TY is the tangent to the circle TVS. If SVT, this angle here is 48, and VS is equal to ST, this line is equal to this line, what is VTY? VTY, you are talking of the angle that is here. You should be able to do that. Then this another question, number 2. If this is circle, in the diagram, TS is the tangent to the circle PQRS. So TS is the tangent to this circle. If PR is equal to PS, so this line and this line are equal. This line and this line are equal. And PQR, this angle is 170. Calculate RST. You are told to look for the value of this angle. Number 3. In the diagram, XAY is a tangent to the circle at A. That is XAY. This is a tangent to the circle at point A. AQ is the diameter. So they said this line is the diameter to this circle of the circle, and CB is parallel to XY. This line and this line are parallel. If BAY is 34, this angle is 34. Find BAQ, the angle that is here. Also ACB, this angle that is here. QBA, this angle here. And CAB, the whole angle that is here. Please make sure you like, subscribe and comment on this video. Thank you.